Good morning, everyone. I hope you're having a good day, and then I hope that you're, staying safe at home and being able to watch these videos with no issues. Uh, so now we're going to enter the last section of chapter 3. We're going to have a quiz tomorrow, so just a heads up. But anyway, now we're going to be talking about the climate regions of the Earth and the climate patterns. So just a little fun, background here. Iceland is a country that actually does not have much ice. It has some glaciers, but for the most part, it's actually a country where there's a lot of geothermal energy, meaning that it has a lot of heat coming from the earth. And this is because it's kind of along where the rift is between the North American and European plates, where they're pulling apart. So it's got a lot of geysers, volcanoes. And so its winters are actually very mild, and the summers are cool and sunny. So it sounds like it'd be a very nice place to visit. One day, maybe I'll get to go there. But in other words, this is a country that is not, its title does not actually equal what it is. And part of that is due to the Vikings, who they actually created when they settled in Iceland, they're like, oh, this place is kind of nice. Well, when other people tried to settle there, they said, don't settle here. It's nothing but Iceland. Go over to the next island. It's Greenland. Greenland being covered in ice. So it's definitely a different, setup. Now, geographers often divide the Earth into climate regions. You have tropical, dry, mid-latitude, high latitude, and highlands. And because climates vary within these broad regions, they're further divided into smaller regions than the major ones. And each of these divisions has its own characteristic soils and natural vegetations, or plant life that grows in an area where the natural environment is unchanged by human activity. So we'll start with tropical climates. Now, tropical climates are found in or near the low latitudes, or the tropics. Remember, in between the tropics of Cancer and Capricorn. They're hot and wet throughout the year, and they have an average, like tropical rainforests, for example, have an average temperature of 80 degrees Fahrenheit. Like that's the average, meaning it doesn't usually get much colder than that, and it doesn't often get much warmer than that. The warm, humid air is saturated with moisture, producing rain almost daily. So it's with rainfall averages about 80 inches. There's a lot of lush vegetation that's common in these areas, especially even though the rains kind of tend to leach out or draw out nutrients from the soil in these climates, meaning that the soil is not very rich, but it's still very, has a lot of very lush vegetation. There's also a ton of wildlife. So lots of different animals. I mean, I remember seeing a stat where they said that we don't think we'll ever discover all of the different insects and birds that live in rainforest climates. There's just no way. Now, tropical rainforest vegetation grows thickly in layers. So you have, different layers. You have tall teak or mahogany trees form a canopy over shorter trees and bushes. You got vines and shade-loving plants growing on the forest floor. And then the world's largest tropical rainforest is in South America in the Amazon River Basin. And then you've also got similar climate and vegetation existing in other parts of South America, in the Caribbean, and in Asia and Africa. There's also tropical savanna, which are climates that have dry winters and wet summers. They're accompanied by high year-round temperatures. In the dry season, the ground is covered with clumps of coarse grass, and fewer trees exist in savanna regions than in the rainforests. So it's more like a plain. And tropical savannas are typically found in Africa, Central and South America, Asia, and Australia. Then we have the dry climates. Now, geographers have identified two types of dry climates, which is both based on the vegetation. So you have desert and steppe climates in many parts of the world. Now, dry areas with sparse plant life are called deserts. Yearly rainfall in deserts seldom exceed 10 inches, and temperatures can vary widely from the heat of the day to the cool of night, and from season to season, meaning it's hotter in the summers, cooler in the winters. Desert climates occur in just under 1/3 of the Earth's total land area, and the Sahara alone extends over almost the entire northern 1/3 of the African continent. The natural vegetation of deserts consists of scattered shrubs, cactus, and plants that tolerate low humidity and wide temperature ranges, meaning these are plants that can live in these, like, that have evolved over time to live in these environments. In some desert areas, underground springs may support an oasis, which is kind of like an area with lush vegetation. Like, it's just like this random spot where there's a water hole and stuff has grown around it. Some deserts have dunes or rocky surfaces, and others have fertile soil that can yield crops through irrigation. Often, bordering deserts are dry, largely treeless grasslands called steppes. So around these around the deserts, you have these dry, treeless grasslands. Like, yearly rainfall in one of these in a steppe is 10 to 20 inches. The world's largest steppe stretches across Eastern Europe and Western and Central Asia, and they're also found in North America, South America, Africa, and Australia. Then you have the mid-latitude climates. Okay, now the world's mid-latitudes include 4 temperate climate regions. Mid-latitude climates experience variable weather patterns and seasonal changes. They also have a variety of natural vegetation. So along western coastlines between the latitudes of 30 degrees and 60 degrees north and south are regions with marine west coast climate. The Pacific coast of North America, much of Europe, and parts of South America, Africa, Australia, and New Zealand have marine west coast climates. In these areas, ocean winds bring cool summers and damp winters. Abundant rainfall supports the growth of both coniferous and deciduous trees. Coniferous trees, most of which are evergreens, have cones, so pine trees. Deciduous trees, most of which have broad leaves, change color, and drop their leaves in autumn. So think like, your oaks and those type, and your maples. Now, typical of marine west coast climates are mixed forests with both kinds of trees. So it's not unusual to see like both kinds of trees growing in a forest in like these areas. You also have lands surrounding the Mediterranean Sea, which have mild rainy winters and hot sunny summers. And the natural vegetation in theirs includes chaparral, which is like these woody bushes with short trees. So it's like it's just like a short bush. Now, geographers classify as Mediterranean any coastal mid-latitude areas with similar climate and vegetation. So such areas include Southern California and parts of Southern Australia. In the southeastern United States and in southeastern parts of South America and Asia, a humid subtropical climate brings short, mild winters and nearly year-round rain. That should sound kind of familiar. The wind patterns and high pressure related to nearby oceans keep humidity levels high in these areas, and the vegetation will often consist of prairie or inland grasslands and forests of evergreen and deciduous trees. So we kind of have a little bit of everything here. In some mid-latitude regions of the northern hemisphere, such as in southern Canada, western Russia, or northeastern China, landforms influence climate more than winds, precipitation, or ocean temperatures do. These humid continental climate regions do not experience the moderating effect of ocean winds because of their northerly continental or inland-like locations. The farther north one travels in these humid continental areas, the longer and more severe are the snowy winters, and the shorter and cooler are the summers. So longer winter, remember, the higher up you go, longer winters, shorter summers. Vegetation in humid continental regions is similar to that found in marine west coast areas, with evergreens outnumbering deciduous trees in the northernmost areas of the region. Okay. Then we get to the high latitude climates. So in high latitude climates, freezing temperatures are common throughout much of the year because of the lack of direct sunlight. As a result, the amount and variety of vegetation is limited. And just south of the Arctic Circle lie the subarctic climate regions. Winters here are bitterly cold, and summers are short and cool. Subarctic regions have the world's widest temperature ranges, varying from winter to summer by as much as 120 degrees Fahrenheit. Just to put that in perspective, that's crazy. But they can go from sub-zero temperatures to above zero, well above. In parts of the subarctic, only a thin layer of surface soil thaws each summer, and below it is permanently frozen subsoil or permafrost. Brief summer growing seasons may support needled evergreens, so they might get the occasional pine tree. Closer to the polar regions, Tundra climate regions are very cold, and here the winter darkness and bitter cold last for half the year, so at least 6 months, and the sun's indirect rays bring constant summer light but little heat. So it's very cold still, even in the summertime. In tundra regions, most of which lie on the far north of the northern hemisphere, the layer of thawed soil is even thinner than in the subarctic. Trees cannot establish roots in these frigid plains, so tundra vegetation is limited to low bushes, very short grasses, mosses, and lichens. Snow and ice often cover more than 2 miles thick. I mean, think about that. That's crazy. Share some of the same and high mountain areas, even along the equator, share some of the same characteristics as the high latitude climates because of the thinning of atmosphere at high altitudes. The higher the elevation, the cooler the temperatures. The natural vegetation of highland climates also varies with elevation. Mixed forests generally lie at the base of the mountain ranges. Higher up, like meadows with small trees, shrubs, and wildflowers line the mountainsides. Okay, and this is just kind of a look at the different types. So basically, the closer to the sun, the more vegetation, the more trees. The further away from it you go, the less trees. It's a good way to think of it. Okay, now climates change gradually over time, although the causes of these changes are pretty unclear. Scientists search for answers by studying the interrelationships among ocean temperatures, greenhouse gases, wind patterns, and cloud cover. And during the last 1 to 2 million years, for example, the Earth has passed through 4 different ice ages, which are eras when glaciers cover large areas of the planet's surface. Now, one hypothesis, or a scientific explanation for these ice ages, is that the Earth absorbed less solar energy because of variations in the sun's output of energy, or because of variations in the Earth's orbit. Another hypothesis suggested that dust clouds from volcanic activity reflected sunlight back into space, cooling the atmosphere and lowering surface temperatures. Again, this is all unsure. Now, human interaction with the environment also affects climate as well. Burning fossil fuels releases gases that mix with water in the air, forming acids that fall in rain and snow. Then you have acid rain, which destroys forests, and fewer forests also can result in climatic change as well. The exhaust released from burning fossil fuels in automobile engines and factories is heated in the atmosphere by the sun's ultraviolet rays, which forms smog, a visible chemical haze in the atmosphere that endangers people's health. So it's like a mixture of smoke and fog, and it's very dangerous to breathe in. Other human-driven changes result from dams and river diversions. And while these projects are intended to supply water to dry areas, they actually cause new areas to flood or dry out and affect climate over time as well. So even though you may be it's, the unintended consequences thing. Like sometimes we will create something with the intent to do good, but there's a consequence nobody expected that ends up being more problematic. Okay, so that's the end of today's lesson. I hope you were able to learn what you needed to know. I hope you've been watching these videos at home if you've been at home, and I hope that you have a great rest of your day, and I'll see you tomorrow.